Hey guys, a warm welcome here from Germany. Today it's Saturday, it's beautiful weather, but I have an interesting topic for you. We have just finished a new animation about the smallest fire extinguisher of the world. We've done that together with some colleagues from Job Group, and this thing, I don't want to get in too much detail right now, you will find in the high voltage battery. And it's really important, or it can be really important when it will be used more and more in the future in order to avoid thermal runaways. So let's have a look at it. Alright guys, so before we dig ourselves into the actual topic, just let's have a look of what kind of thermal issues can appear on a high voltage car. So there can be serious ones, but there also can be, easy ones, which will cause a DTC thermal warning, but which will be basically, when you do the diagnosis on the car, you will find out it's not that bad. So we see it right now here, what happens in that animation. There you see you get one temperature warning from one cell or respectively from one temperature sensor. So when there's really a thermal issue, you won't just have an alarm from one sensor basically. So and this especially over the time, when nothing changed on this view basically, on this warning situation, then most probably there won't be a damaged cell or something like that, but there will be a broken temperature sensor. So of course you have to do all the work, open the high voltage battery, exchange the temperature sensor, but it's not a critical fault. Let's jump to the other animation. So when we have a look now at this one, it will be a little bit different, and there you see what has happened. So the battery got damaged from the outside, and now you don't have just one warning, but now you have a couple of warnings, and the heat wave is spreading over the high voltage battery. So in that case, you really have an issue, and it looks like that this battery can, or these single cells can run into a thermal runaway. So, but what does it mean, a thermal runaway basically? So therefore let's have a look at this picture. Basically a thermal runaway is not just appearing just like that when your car is just at home and nothing happens to the car. A thermal runaway can appear, for example, when there is an overload from the electrical side. So this is why it happens a few times when you charge the car, and especially when you charge it at very high currents, so high level charging, high power charging. There, now and then it just came to the situation that the electrical load was too much and the cell was heating up and went into a thermal runaway. Same can happen when there is too much heat from the outside. So when something else burns, for example, and it reaches the high voltage battery, it also can lead to a thermal runaway. Or, like we've seen in the animation before, when the high voltage battery just gets damaged. What happens right now? And what is the thermal rate? So right at the beginning you have, for example, a maximum allowable temperature of 60 degrees. That's okay. But we're going upwards with the temperature. So here with 70, it starts that the electrolyte starts to evaporate. Now there's already a built-in safety thing inside each cell. This is what you call the shutdown separator. And he gets activated. He begins to get a little bit like, not really liquid, but he gets activated, and that shuts down the lithium ion transport. So the ions can't pass the separator anymore, so no current flow basically through that cell. But the problem is when the temperature rises further, there's another border or level, what you call the breakdown temperature. And when the breakdown temperature is reached, this is what you have here, by above 130 degrees, the separator is melting. And right now you have an internal short circuit. So when the separator is gone, you have this internal cell short circuit. And then it's getting critical, because then you have an exothermic reaction. You see there's an exponential temperature rise, and then you run into the thermal runaway. And what is remarkable about the thermal runaway, it is unstoppable. So once this temperature, this critical temperature is reached, like here, for example, above 250 degree, the thermal runaway will happen. You can't do anything against it. It will go up to 600 degree and more, and this will course into a fire. So, and now we get back. Oh, let's first have a look. I just have another video here which shows the thermal runaway. So this is exactly what happens here. Sorry for the low quality, but I think you get an idea what happens there. So here someone just poked a battery, lithium-ion battery, from the notebook or something like that. So there is this external damage to it. It causes the temperature to rise because you have already created the internal short circuit here through the knife. And then you see what happens here. And this is why a thermal runaway is really, really serious. So, but now now let's have a look at the new situation. And what you see here, right at the entrance of the high voltage battery, and here, 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 and here, that are the so-called thermofuses. Okay, so this is what is developed together with Job Group and Intercable. These little guys there, they can do something really, really great. And what is really valuable about them is the thing what is inside, and that's a very smart thing. We see it in a second. This is called E-bulb. So, but right now we have the current flow through the high voltage battery. But something happens with the high voltage battery. So the current is running through all over this so-called thermal fuses. So they are just, like forwarding the current from each package to each package. And then something happens to the high voltage battery. Let's say it got damaged, whatever. And this leads then to a temperature rise inside the high voltage battery. Here you see it now. So the cells starting to rise. So the first one was the one over here, so this is the center of everything, the source of everything. So, and this is why we're focusing now that thermofuse over here. So let's have a look inside. So what you see here right now, we have here our temperature, and this is a look inside or view inside the thermofuse. So current flow is running over here, is going over here, 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 and on the other side. So in that under that circumstances, in that state, nothing special about. It's just like a metal connection, which is conducting the current. So, but now the temperature rises. And there's a critical temperature, not 100 degree, but what Job Group found out, or what the people say in general, it's round about 165. So you have to stop the temperature from going up further than 165 in order to prevent a thermal runaway. And what happens then? And there you see it. You know, you've seen what happens here. So when this temperature, this critical temperature is reached, then this E-bulb, so this bulb here in the middle, which is filled with a certain special gas. And then this E-bulb is just exploding. And because this E-bulb is basically carrying that part here, which is connected to a spring, and as soon as this thing is gone, the connector here will run down and will interrupt the current flow. But now we have the problem. So this is just the thing which stops the cell, the high voltage battery, from heating up even more. But it would be a really bad thing when we now would stop a possible fire by stopping increase of the temperature, but causing another fire because we have interrupted the current flow like in a millisecond. So what happens here? I mean, we have here high voltage. We have hundreds of amperage running over this fuse. And when we suddenly disconnect this connection, then we will create a spark. And this spark then could lead to another fire. And in order to avoid that fire, this gas inside the E-bulb is the critical component. So that means as soon as the gas comes out, it will directly kill any kind of spark which will be created because of the interruption of the current flow. There you see it, it's gone, no fire. So temperature is stopped basically. Temperature is stopped from increasing, and yeah, the high voltage battery has itself avoid a thermal runaway. Pretty cool thing, isn't it? On the other hand, I mean, that's a no-brainer now. You can't go on driving with that car anymore. This car is still critical because, yeah, one fuse was activated here, but you do not know about the status and the exactly circumstances which has led to this temperature rise. On the one hand, the thermal runaway could be stopped or at least delayed. Okay, so it's not always the case that you can stop the thermal runaway. That depends on different things, but at least you can delay it. Let's say we have stopped it here. So the temperature rise is under control and there is no current flow anymore. So this critical temperature of the exotherm reaction of 250 degrees is not reached. So the separator is basically not melting completely. And now, yeah, the car needs to get to the workshop. They need to take special care of the car as there is a high voltage battery problem with a thermal problem. So this is really serious. You can't just put it inside the workshop. And then you need a high voltage technician who can open the high voltage battery and exchange the cells and the fuse. And then you're good to go. So very cool thing in my eyes. Definitely better than a fire on the high voltage battery, which obviously will kill the whole car. So thanks to Job Group and Intercable. I hope you enjoyed the video and stay tuned for more. Have a great weekend. Bye bye.